Hey, welcome to Stat Stars. My name is Mubashir Manzoor, and today we are going to learn SPSS in 30 minutes. Here is the content which we are going to learn today. We will learn how to import data in SPSS, finding, detecting missing values, checking reliability, computing variables, doing demographic analysis, correlation, regression analysis, and much more. So here's the first thing, how to open import data in SPSS. I have a file in Excel form. So it's so simple. I will just click on file, then import data, select Excel, select the Excel file, just hold for a while. Click OK. Wait for the command. So here we go. Here is the Excel file. There are two views. One view is variable view and other one is data view. As we can see, here is the data which is encoded. I've just collected the data from the questionnaire and encoded them with these numbers. The second task is how to find and detect missing values from data. As you can see, the data is in large form. It is very much difficult to find the missing values from all data because the data is in large form. So we can check the missing values by clicking analyze, then descriptive statistics, frequencies. I will select all these items, then press OK. So here's the table occurs named statistics. You can see that there is written 1, 1, 3, 2. It is showing the missing values in these variables. The next step is how to replace missing values. As we have found, there are some missing values in this data. I will click Analyze, Descriptive, Frequencies. So here is the table which is showing that there is some missing values in the variables. I will simply note down all these missing values having in that variables. I will note down all that variables like GS10, GS11, FE1, FE3. I've written all those variables which have missing values. Now I am going to replace these missing values. I will click transform, replace missing values. So here is the action box. I have written down all the variables which have missing values. Now I will select all these variables which have missing values. I have selected all these variables. We'll click OK. So here the command runs. Now when I go to the data view, there are 4 new columns generated. GS10, GS11, FE1, FE3. Now I will consider all these columns for further calculations. The fourth step is how to check reliability of the data. It is very important to check whether the data is reliable or not. I will click simply on Analyze, Scale, reliability analysis. I will click all the items of one variable, scale that label. So here is the reliability statistics that Cronbach's alpha, which is showing that 0.632. Always remember the normal value of Cronbach alpha is larger than 70. Through that I will check all the Cronbach values of all variables one by one. Again through same way. So we can say that the reliable statistics Cronbach alpha value is 0.841, which is a normal value because it is larger than 70%. Again, I will select other values, other items of the variables. As we know that I have some other new columns which have the replaced missing values, so I will select those. Again, I will label the scale. So here we can see the Cronbach's alpha value is 0.961, which is a normal value because it is larger than 7.7. So moving to other variable, I will select all the items. Again, keeping in mind that I have a new columns generated. So here we can see the Cronbach alpha value is 961.961, which is larger than 70.70. The fifth step is how to normalize the data. Here normalizing means to delete all those items which is causing that variable less reliable. I will simply check the reliability of variables. Here we can see the Cronbach alpha is less than 0.70. That means that variable is not much reliable. I will simply detect the item which is causing less reliability. So check scale if item deleted. So I have the variable named EE which has less reliable, and if I will delete it, the variable will become much reliable. I will simply delete this variable. As you see, I have deleted. Again, analyze scale reliability analysis. As we see, the item is deleted. Scale if item checked off. Now we can see that the variable is now reliable. The sixth step is how to compute variables. As we can see, there are different parts of each variable. Each variable is divided into different part. So it is very important to compute all these variable into one variable. I will click transform. I'm going to transform the variable EE in one variable into one variable. I will select main from the function group. So One by one, I will select all the items of EE. We'll put commas. Simply name the target value. Press OK. So wait for the command. Now when we go to the data view, we can see that there occur one new column named EE. Simply, it includes all those items of EE. Again, analyze, transform, compute variable, moving to the next variable, which is VF. I will select all those items one by one. After that, I'll put commas, name that target variable. Again, press OK, wait for the command. Simply, I will do it with each variable. I will select the other variable. One by one, putting commas in it. I am selecting all those items of one variable. The purpose of that is to convert all these items into one item or one new column, so I can do regression and correlation analysis. Name the target variable. Okay. We'll move to the next variable. The next variable is FE. Always remember that I have the new columns which were replaced before due to the missing values in those. Name the target variable, press OK. Now you can see that I have computed all those variables. I have converted all items of one variable into one column. So now we can do regression and correlation analysis. The same step is how to remove outliers from the data. So what is outlier? Definition of outlier is an outlier is an observation that lies an abnormal distance from other values in a random sample from a population. So it is very important to remove the outliers from the data to get a permanent and a very reliable results. So I will click analyze, regression. We'll select linear. So here's the action box. So here is the action box. I will select the dependent variables and independent variables according to my own model. So I've selected VF as a dependent and other three variables as independent variables. Now we'll click save Mahalo base. Distances, I will check it. We click OK. Wait for the command box. So here we can see that there is a new columns named Mahalo base giving different values. I will arrange it in descending order. So here are some values which are considered to be as outliers. It is very important that how can we find that the values are considered to be outliers. I have a chi-square distribution table. The significance level in social sciences is 0.05. Degree of freedom is the total numbers of IVs I have. So the 7.81 is a significant values, and the values which are greater than this values is considered to be the outliers. So I will simply remove all the data which is larger than 7.81. So I'm going to delete all this data. So I have deleted all this data. Now the outliers are removed from the data. I have a significant and the true are much more reliable data. The eighth step is how to do descriptive statistics. So here I have the data. I have computed variables. I have outliers which are removed. I will click analyze, descriptive statistics, descriptives. I will select all the computed variables, check mean, check standard deviation, check minimum, check maximum, kurtosis and skewness. Continue. Press OK. So here is the table named descriptive statistics showing different results. For the presentation, I will copy, select as Excel file, open the Excel file. I've pasted the data here. I'm doing this just to represent the data or make the data into a such form through which we can easily learn, easily interpret. So we are also learning how to represent the data. I will delete all the columns with standard error. I will only select these four columns: mean, standard deviation, skewness, and kurtosis. So here we can see these are four columns. The ninth step is to do demographic analysis. It is very important to do demographic analysis because through that way you can present your data into a graphical form. So I will click analyze, descriptive statistics, frequencies. 。 . 。  . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . You can select on only one thing, more than one things, one item, more than one items, whichever you want. You can select the chart of your own type. So wait for a while. So I'm opening different kind of charts just to tell you that you can make the chart or bar of your own choice. Their frequency analysis. So in a simple form, you can do all this demographic analysis according to your own choice. As you can see, I did. The next most important thing, how to run correlation analysis. So analyze, correlate, bivariate. So by selecting all the variables, I have a correlation table. I will again put it on Excel sheet just to represent and make it much easier to interpret that data. So I'm converting that correlation table into a form or into a shape through which can I can easily interpret. I would delete these rows, remove Pearson correlation column. I am making a table which is a proper correlation analysis table. Put mean and standard deviation here. So I have the table of correlation analysis which can be easily interpreted. I will delete all the items which are upper than the diagonal. As you can see, I have deleted all this item above the diagonal one. And on the place of one, I will put the Cronbach alpha values of each variable. With the SPSS, you can also learn many other techniques which are much necessary and fundamental for using Word and MS Excel. I'm putting all the Cronbach alpha values here. So again, as I said, that I'm making a table which is more representable and much easier to interpret. So in correlation, it is very important to present the data so a viewer or reader can easily interpret that data. So correlation significant level is always lies between -1 and +1. So here we can see the relationship of correlation amongst different variable. EE, VF, all these variables are related with each other significantly because the correlation is significant. The next step is how to run regression analysis. I have the variables. Click analyze regression linear. So I will choose the variables according to my model. Culinarity diagnostics, Durbin Watson. Okay. So here is the table. Here is the result showing different tables, showing different kind of stats which can be interpretable according to the model, according to the hypothesis we have made. So all these results depends upon the model. If you have the model clear in your mind, so then you can easily interpret all these tables. These regression tables are showing the relationship with DVs and IVs among themselves. So in that way you can run regression analysis. We have coefficients, collinearity statistics, F statistics. And if you have found this video helpful, then must like and subscribe this video. Thank you so much.